Okay, everyone, we're going to finish this section off with basically a discussion of what can go wrong. What can go wrong in a hypothesis test? So think about what we're doing in a hypothesis test. We're deciding, should we reject the null hypothesis and accept the alternative, or should we fail to reject the null and continue to believe the null hypothesis for another day? And so we could either be right or we can be wrong. In both of those cases, we could be um, doing the right thing or we could be doing the wrong thing. And so there's two different ways that things can go wrong, and they're called type 1 error and type 2 error. So that's what we're doing. So just by way of analogy here, there's a really clear analogy between this terminology, false positive, false negative, and type 1 and type 2. So what's a false positive? So in a medical context, a false positive is what? It's when when the test says that somebody has the disease or they have the condition, but they actually don't, right? So let's write that down. It's false positive is when um, the test or when the doctor um, 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 decides, or let's say concludes that a patient has the disease, um, even though they don't. They actually don't. They don't have the disease. Okay. Now, what's a false negative? A false negative is when the doctor says you don't have it, but you actually do. That's probably worse, right? You know you're fine, you're healthy, but you actually do have the disease. You just don't realize it. It's when the test or the doctor concludes that you don't, that the patient does not have the disease, even though they do. Um, so type 1 error is going to be like a false positive. Now let me try to explain that. Type 1 error is, it happens when the null hypothesis is true, but maybe I'll write it the same way that it's written up here. So it's when um, we reject the null hypothesis, even though it's true. So basically we're saying we reject the null hypothesis. We're basically saying something is happening, right? Because the null hypothesis always says nothing is happening. So we're saying something is happening. There's some significant effect, you know, even though there isn't. There is nothing. There isn't. That's kind of the translating it into slightly more familiar terms. And that's exactly like a false positive because it's saying um, let's do type 2 first, and then I'll say that. So type 2 is when we fail to reject the null, when we fail to reject the null hypothesis, even though it is false. So that's like saying we fail to reject the null. It means we continue to believe the null hypothesis. So we continue to believe that nothing is happening. we continue to believe nothing is happening, even though something is happening. So how do we trace out this analogy really clearly? So in medicine, the null hypothesis is that the patient is healthy. The patient has no condition, no disease, at least not that disease. The alternative is that the patient has disease, has some disease, whatever it is. So let me put this in a box here. So how do we draw out the correspondence here? So here we're saying, for type 1, we're saying we reject the null. So we say the patient is not healthy, even though they are. They are healthy. So we're saying reject the null. So we're saying they're not healthy, even though they are. So that is like a false positive, right? Because we're saying they have the disease, even though they don't. So that's like a false positive. Whereas type 2 is when we say we fail to reject the null. So we believe they're healthy. We say that the patient is healthy. I should be really careful here. It's not that they are, it's that we say they're not. We say the patient is not healthy, even though they are. Or maybe even better, the doctor says the patient is not healthy, even though they are. That's a false positive. And now this one we fail to reject. So we say the doctor says fail to reject the null. So we keep thinking they're healthy. Doctor says the patient is healthy, even though that's false. Even though they're not. Even though they are diseased. So that would be a false negative. So it's kind of a logic puzzle to get these things going in the right direction. And let me move this a little bit. But I find it helpful to think that type 1 is like a false positive. So another way to put this is that type 1 is an overly hasty conclusion. We're saying, oh, you have the disease, even though we shouldn't have leapt to that conclusion so easily. So type 1 is a kind of hasty error. A type 2 is a kind of overly cautious error. Type 2 is saying, no, I don't think anything's going on. I think you're healthy. Nothing's happening, even though there really is something going on. Okay, so there's a little acronym here that we can use, a memory device, routine for fun. So if you take that phrase, if you just look at the consonants, R, T, N, F, R, F, N, it tells us that type 1 error is when we reject R, T, N, reject a true null. That's a type 1 error. F, R, F, N is when we fail to reject a false null. Fail to reject a false null. That's a type 2 error. So that might help you. And the last way to remember this is this kind of funny cartoon here, or funny, maybe funny stupid is the word. What's the default? Say we're talking about pregnancy. The null hypothesis is that you're not pregnant, right? Typically, a person is not pregnant. Even a woman generally is not pregnant. The alternative would be that they are pregnant. So this doctor here is making a type 1 error because they're saying, hey, you're pregnant, even though, I mean, there's probably a good reason to think that this person is not pregnant, right? So that's rejecting a true null. This man is truly not pregnant, but we're rejecting that and saying, no, he is. And this doctor is saying, no, you're not pregnant. It's just even though clearly there's something going on here. So this doctor is failing to reject the null hypothesis, even though it's false. So fail to reject the false statement that not pregnant. Whereas this one is rejecting the true statement that H0, you're not pregnant. Okay, I don't know if that helps. Everything about these words is tricky, so even the ways to remember it are tricky. Okay, now what's worse, a type 1 error or a type 2 error? Well, it depends, but often, let's think here. So what's worse, a false positive or a false negative? False positive is if you say, you have this disease, we have to start treating you, even though you don't have it. So that's not that bad, right? It's saying you're going to get the treatment even though you don't need it, and it might be inconvenient. So a false positive is not the worst thing. It's like if with the COVID-19 testing, say you get the test and it says you have COVID-19, you might be very stressed out about that, but you're not actually sick. And so hopefully you would do another test and you would find out that no, you're not sick. Maybe so. What's worse here is a false negative. The test says no, you don't have it. You don't have COVID-19, and then you go on living your life for a little while longer, and you pass the disease on to other people. You get more and more ill yourself. So, at least in the medical context, a type 2 error is a worse error to make. But in other situations, we'd have to think about it case by case. Okay. So one more page here, 2 more pages. It's a long one, isn't it? Okay. So let's go back to the medical context here. Consider medical tests in which the null hypothesis is that the patient does not have the disease, and the alternative is that the patient has the disease. We've actually kind of covered this already. I forgot that I had this. What would be the meaning of a type 1 error? So let's write down. The null is that they no disease. H1 is that they do have disease. So a type 1 error, if we use our acronym routine for fun, oh, I forgot the R, that's why, routine for fun. Type 1 is the first 3 letters, so we failed to reject a true, no. Okay, sorry, it's been a long evening here. RTN means reject true null. So type 1 is that we reject a true null. So we say, so you don't have the disease, but we say you do have the disease. We say you have the disease even though you don't. Okay, now this is that's what I just said on the last page at great length, right? What would be the meaning, but it doesn't hurt to repeat it. What would be the meaning of a type 2 error? So type 2 is the FRFN is fail to reject a false null. So the null is false. It's false that you have no disease, that you do have a disease, but we don't reject it. We keep thinking it's true. So we think or say that there's no disease. We continue to say that there's no disease, even though there is. You do have a disease. So that's the false false negative, and this one is the false positive. Okay, now give an example of a situation where a type 1 error is more serious than a type 2 error. When would a false positive be more serious than a false negative? Okay, so one example would be, let's say, DNA matching. Let's see here, DNA matching. So let me explain that. In that case, the null hypothesis would be that there is, let's say, DNA matching for criminal evidence, right? For crime scene evidence. So we're going to say that if your DNA matches the crime scene, then you're guilty. DNA matching for a crime scene, which is medical. The null hypothesis would be that there's no match, right? The alternative is that there is a match. Why is that? Why is the null hypothesis that there's no match? Well, that's our default assumption, right? If you just have a random person, probably their DNA doesn't match. So we would start out thinking this is not a match, unless the computer says, there's enough overlap that it looks like a match. So what would be a type 1 error here? It would be, type 1 error would be a false positive match. So it's saying that your DNA matches, even though we say that the test says your DNA matches, even though it doesn't, even though you weren't there, even though your DNA is different. So that would be a bad error, right? That would be saying you're guilty even though you're not. Type 2 here would say that the type 2 error here would be that we say there's no match even though there is a match. So that would be like the criminal gets off, right? The criminal gets let go. But in our legal system, we consider that less bad, right? It's better to, it's worse to imprison an innocent person than it is to let go the guilty person. That's what our legal system is based on. So what about an example where type 2 is more serious? Well, that would be like testing for, let's say, cancer. In that case, the null hypothesis would be that you have no cancer, and the alternative would be that you do have cancer. So then type 2 here would be saying, let's do our acronym, routine for fun. Type 2 is you fail to reject a false null. So false null would be you don't have no cancer, so you do have it. So the test says test says you don't have cancer, but you actually do. And that's bad, right? I mean, it could get much worse. And type 1 error here would be saying, no, you do have it, even though you don't. And that's scary, but it wouldn't actually affect your health, right? You don't actually have cancer. Okay. So the situation determines whether one error is worse than the other. Now, a couple of true-false questions, and then we'll wrap it up. I forgot something. So it turns out that the probability of making a type 1 error, the probability of making a type 1 error is actually exactly alpha. It's not obvious, but it's exactly alpha. And so that's the meaning of alpha. It's the likelihood of rejecting the null hypothesis even though it's true. So in other words, it's a false positive. And remember, we had a word for 1 minus alpha. That was called the confidence level. Alpha itself is called the significance level. Significance level. 1 minus alpha is called the confidence level. We also defined the probability of making a type 2 error. Well, that's called beta. And it doesn't have a nice name like that, but 1 minus beta is called the power of a hypothesis test. And we're not going to study the power in this course, but it is something that comes up when you're actually using hypothesis tests in the real world, but we can't do everything. So we're not going to analyze it's harder to analyze type 2 errors. That's the reason. We're going to do a little bit of this. We will do this, but not this. Not this. Okay. All right, so a few true-false questions, and then I think that is okay. 22 minutes, okay. True or false? The p-value is the probability that the null hypothesis is true. And if you're getting tired, or if your comprehension is starting to fall apart a little bit here, this sounds like it could be true, right? The p-value is the probability that the null hypothesis is true. It kind of sounds true, but it's totally false. What is the p-value? The p-value is, the definition is it's the probability of observing an outcome as extreme as the actually observed outcome, given that the null hypothesis is true, given that the null hypothesis is true. And so if we have a small p-value, a small p-value actually means that the null hypothesis is not likely true. Which is consistent with this interpretation, but it's not the right interpretation. We don't attach a probability to the null hypothesis being true. In fact, if you were really strict about it, you'd probably say the probability is 0 that the null hypothesis is true, because the null hypothesis is exactly a specific number. What's the probability that a coin is exactly fair? I guess it means if you took all the coins that have ever been made, what's the probability that it's exactly fair? Well, nothing's exactly anything, so it's 0. Okay. So if the null hypothesis is true, then the level of significance alpha is the probability of making a type 1 error. That's true. If H0 is true, then we reject the null. Then we're going to reject H0 for only the most extreme 5% or extreme fraction alpha of all samples. If H0 is true, then we're gonna end up rejecting H0 for only the extreme fraction alpha of all samples, which is exactly saying that the probability of rejecting H0 that's the probability of making a type 1 error. That's alpha. Okay, now to really understand this little statement, you probably have to read it 10 times or maybe more. This is very intricate logical structure going on here. It's not going to make sense the first time you read it. You have to read it, like I said, 5-10 times. Let it drift through your subconscious. Maybe you'll have dreams about type 1 errors and it will come to you then. Okay, if the null hypothesis is true, then the level of significance alpha is the probability of making a type 1 error. That's exactly what it is. Okay, a type 2 error can only occur when the null hypothesis is true. Okay, let's think about that. What is a type 2 error? It's routine for fun. Type 2 is when we fail to reject a false null. Type 2 means we fail to reject a false null. So it can only happen, that can only happen if the null is false. Fail to reject a false null can only happen if H0 is fail to reject a false null is false. So this is not true. A type 2 error can only occur when the null hypothesis is true. So this is false. What would be true would be a type 2 error can only occur when the null hypothesis is false. It's kind of like saying, what is a type 2 error? It's like a false negative. A false negative can only occur when you don't have the when you do have the disease, when you're not healthy. Not healthy means H0 is false. A false negative can only occur when you are not healthy. Okay, so I was going to say one more thing. Right. So this section of the book is quite heavy on concepts and definitions that they're going to get reinforced as we go down the chapters 8, 9. And so I want you to study this carefully, but keep in mind that it's a lot to absorb all at once, and it's going to keep coming back. And so you're going to have multiple chances to really absorb these terms. Okay, so that's the end of our introduction. Next time we're going to look at hypothesis testing for P, for population proportions. We're going to slow it down. We're going to do lots of examples and a few variations, and then we're going to move on to means, and then we're going to do two populations. Same things with two populations. All right, so I'll see you in the next video.